So when we're talking about the properties of slope of lines, basically we're talking about the direction in which, or what's happening with a line. Is it going up? Is it going down? How steep is the line? And what does that mean in terms of a rate of change? So the different types of slope that we have a positive slope. So on a positive slope, we notice that the graphed line rises from left to right, and it goes up. Kind of just keeps going up like this. In the equation y equals mx plus b, the m value will be positive. So an example of that would be, y equals 4x plus 3. So the rate of change, or the slope of this line, is a positive value, in this case positive 4. A negative slope, the graph falls down and to the right, or it falls down and to the right, just like this. And in the equation, the slope value will be negative. So an example, just like one from above, example, y equals negative 4x plus 3. So the slope here, or the rate of change, is a negative number. A line that has a zero slope, the graph represents a horizontal line. So there is no change in this line at all. There is no increase or decrease in value for that line. In the equation, the m will be 0. So if I'm going to write that out, y equals 4x plus 3, for example, well, if I make this 0, I'm left with 4 times 0 is nothing, so in this case it would be y is simply equal to 3. And a slope that is undefined is a straight line up and down, just like this. So the line is vertical, and in the equation, y equals mx plus b, m will be undefined, or in this case, x would be equal to, it looks about to be 3. So the x value of this line is just 3. What that means is that this line does not touch any other point other than x is equal to positive 3. That's the only line that it touches. So when we're identifying types of slopes, we look at the equation, we identify the type of slope, the y-intercept, and then describe the line. So for y equals mx plus b, I think we're missing some items here. I'll just draw them in as we go along. So y equals mx plus b, the slope is m and the b is the y-intercept. So for each equation, identify the slope as positive, negative, 0, or undefined. So our first one is y equals negative 2x plus 5. So what is the type of slope? Well, the type of slope is negative, and we can see that here, the negative sign right there. The y-intercept of this line, where does the graph touch the y-intercept? In the point y equals mx plus b, b represents the y-intercept. So in this case, positive 5 is our y-intercept. And then describe the line. Basically, is it going up or is it going down? Well, if the slope is negative, it falls down. Next one, we have y equals, it's supposed to be 2 over 3. 2 over 3x minus 8. What is the slope? Well, it is a positive slope. The y-intercept is negative 8. And if the slope is positive, that means it rises up. Our third example, y equals 3x minus 9. What type of slope is it? It's a positive slope. The y-intercept, in this case, is negative 9. And then describing the line, well, it rises up because the slope is positive. Rises up. This fourth one, y equals negative, that's 3 over 4. x plus 2, what type of slope is it? It's a negative slope. What is the y-intercept? The y-intercept is positive 2. Describe the line. Well, it falls down. Y equals 2. The type of slope, well, there's no slope, 0 slope. The y-intercept is simply positive 2, y equals 2. And what type of line is it? Horizontal. X is equal to negative 4. What type of slope? Well, that is undefined. Is there a y-intercept? No, or none. And then describe the line. It is a vertical line. Slopes of parallel lines. So if we look at the equations of these two lines, line A, y equals 2x plus 2, well, the slope is 2, and the y-intercept is 2 as well. We can see that here for line A. That's where the y-intercept is, and the slope is 2 because we determined that from the equation. Line B, the slope is, change the color real quick. For line B, the slope is 2 from we're looking at the equation, and the y-intercept is negative 4. And we can see that here. So when two lines are parallel, we can kind of infer from what we're looking at here. When two lines are parallel, the slope is the same. And then an equation, the y-intercept, pardon me, is different. Right? These two y-intercepts, this y-intercept and this y-intercept, are not the same, but these lines clearly are parallel, or they're like train tracks. If this y-intercept was the same as this y-intercept, well, that would just be the same line. So for identifying slopes of parallel lines, the equation for a line A is y equals 2x plus 6. Assuming line B is parallel, what is the equation for line B? So this is line A, gives us the equation of the line y equals 2x plus 6. So assuming line B is parallel, okay, so this line's parallel, what is the equation for line B? Well, for line B, I know that the slope is, well, the slope is 2 here, the slope has to be 2 here. And then what is my y-intercept? Well, I just simply look at this line and identify where the line touches the y-axis. In this case, it is negative 4. So then the equation of this line is y equals 2x minus 4. When we talk about steepness of a line, or a line is either more steep or less steep, a slope that is more steep will have a larger coefficient of x in the equation, or it will have a bigger number. The slope that is less steep will simply have a smaller coefficient of x in the equation. So our examples that we have here, example 1, positive slope. So for the equation, y equals 3x minus 2, if I'm going to create an equation that is less steep, I need to make the coefficient of x smaller than 3. Y equals 2x minus 2. That one is less steep. If I'm creating an equation that is more steep, I need to use a coefficient that is greater than 3. Y equals 4x minus 2. When we talk about negative slopes, for the equation y equals negative 3x minus 2, I'm looking for something that is less steep than this equation here. So when I have less steep, I'm actually looking for something that is closer to 0. So in this case, y equals negative 2x minus 2, and something that is more steep, again, looking for a number that is larger, y equals negative 4x minus 2. the coefficient of 2 is less than 3. The coefficient of 4 is more than 3. The negative sign here simply means that the line is going down and to the right, or it's moving down like this. So the numbers are still going to be reflective of either less steep or more steep. So 4 is clearly bigger than the number 3, and that negative sign simply means that the line is going down instead of up. So look at the absolute value of the number and ignore the positive or negative sign. And I just kind of explained why we do that. Identifying the steepness of lines. The equation of a line is y equals 2x minus 6. Write an equation of a line that is less steep and more steep. Okay, so starting with less steep, y equals, I need anything less than that. Well, I can simply go x minus 6 or 1x minus 6. Something that is more steep, y equals any number that is larger than 2, 4x minus 6. Equation of another line, y equals negative 5x plus 2. Write an equation of a line that is less steep. Again, a number that is smaller than the absolute value of 5. Y equals negative 4x plus 2. A number that is more steep, I'm looking for a coefficient for the x value that is larger than the absolute value of 5. Y equals 6, negative 6x plus 2. So hopefully this kind of helped clarify what we're doing when it comes to properties of slopes and lines. Again, big takeaways would be what is a positive slope, negative slope, and then the other one would be the steepness of lines, knowing that the coefficient in front of the x term dictates whether or not the line is steep, less steep, or even less steep still.